In the previous video, I asked you a question. Can we have motion in 4 dimensions? Because see, when we say motion in 1 dimension, I'm moving in only one of the axes. 2 dimensions, 2 of them. 3 dimensions, we have 3 axes, x, y, z, they are mutually perpendicular, we move it. But when I say 4th dimension, see, 4th dimension is very hard to imagine, correct? Because x, y, z, it's just basically it's a space, it's spatial, so you can easily imagine. But how to imagine the 4th dimension? It's very hard, right? That's why time comes into picture. That is, we define the position using time. Okay, that is, at 2 seconds, this was the position. At 10 seconds, this is the position. So we use time also. So basically, whenever time is there, we call that as the 4th dimension. Okay, like how we have x, y, and z, t, that is the time, becomes the 4th dimension. So we have x, y, z, t. Okay, so motion in 4 dimension is possible. That is what we actually use in day-to-day life, like time. Time also comes into picture. Okay, for simplicity, what we'll do, we don't usually consider the time. Okay, so time comes into picture whenever it is needed. Alright? Okay, now, when we say the position, we were defining, correct? So, we also have to have one frame of reference. Like how we said that x-axis is a reference line, like same way, we need to have a frame of reference. When we say frame of reference, I can have 2-dimension frame of reference also. Okay, like x and y. For a 2-dimension point, x and y, this is basically the frame of reference. Okay, now even time can also be the frame of reference. Okay, even time, because time also is one of the dimensions what we are using, right? So time can also be the frame of reference. So when time comes into picture, so what we say is we have inertial frame of reference and non-inertial frame of reference. Okay, these are the 2 types of references. Now, a simple example to understand these 2. See, when we say inertial frame of reference, that is, the frame of reference is constant and we are moving. Okay, we are moving. But when we say non-inertial frame of reference, basically the frame of reference is also moving. Okay, like simple example. See, suppose, let's say, imagine you're somewhere standing, okay, and let's say a city bus is moving. If a city bus is moving, if you look at the bus and the person who's sitting inside the bus, what happens here? So basically the person and the bus both are moving, correct? So here there is motion, right? There is motion. So this is non-inertial frame of reference. Okay? Whereas a person who is sitting inside the bus, if he sees the bus, for him, bus is not moving, correct? Like imagine, if you are sitting inside the bus and if you look at the bus, do you think that the bus is moving? No. See, you will get to know the bus is moving only if you look at outside the window, correct? So that means for the person who's sitting inside the bus, if he looks at the bus, that is inertial frame of reference. Inertia, that it's not moving. Understood? There are 2 types of reference. Alright?